Okay, we're going on now to topic 7.2. Again, we are dealing with radical expressions, and at the end of 7.1, I said there was a connection between radical expressions and fractional exponents. So again, you're going to get some of this in the classroom, but I thought I'd just show you something here. That 4 to the 1/2 power, which is a fractional exponent, is the square root of 4. 8 to the 1/3 power is the cube root of 8. And you might say, well, what's going on here? Well, let me just show you something. That whenever you have a fractional exponent, what is in the denominator is your index number. So once again, whenever you have a fractional exponent, what is in the denominator of that fraction is the index number of your radical expression. And whatever is in the numerator of that fraction is the exponent on the radicand. So, can you see that writing something in its exponential fractional form is the same as the radical expression form? It's just another way of showing the very same thing. And we will use that. Now, how long do you have to do these problems before you memorize that? Well, that's up to you, and again, through practice, hopefully you can memorize. So what they're asking us to do here is to take these fractional exponents and put them into radical form. So let's see if we can do this. Well, we're going to put the radical sign. This is our radicand. The denominator of that fraction is 4, so that will be our index number. And I'm putting a 1 there, but remember, we don't put the 1 there, just as we don't put the 2 there if they're square root. So again, convert this to its radical form, radical sign, radicand. Our index number will be 3. Our exponent is 1. Now they said to convert it and then simplify if you can. So the cube root of 1,000 is going to be 10. Now for this one, again, it's a fractional exponent. We're going to convert it to its radical form, PQR, and the exponent, the denominator, will be our index number. Now I could put the 2 there, but again, you don't write the 2. If there's no number there, the 2 is there, and we don't put the 1 there either. And here, again, radical sign, x to the 3rd, y to the 4th, that's my radicand. My index number will be 5, and this is all to the 1st, so we don't put the 1 there. All right, number 11. The radical sign, our radicand is 8. The denominator of our fraction is our index number. And we're going to raise, and usually when we have something like this, we put the 5 out here. Now you could put it there as well, but you're going to see why this is a better place to put it. Because now we take the cube root of 8, which is 2, and we raise 2 to the 5th power, which is 32. Okay, in this one, it's going to be the square root of 36 c to the 6th, and then that whole thing is going to be raised to the 3rd power. Now, the square root of 36 is 6. The square root of c to the 6th is c to the 2nd. I'm sorry, c to the 3rd, because you're dividing it by 2, and you're raising that whole thing to the 9th. Oh, I'm sorry, 3rd. Now, 6 to the 3rd, I should remember that, but it's 216. This is going to equal 6 to the 3rd is 2/16 c to the 9th. That's where I got the 9 from before. I'm thinking ahead a little bit. Now, for number 12, what they want us to do is to convert from radical form back to fractional exponents. So, let's do that. So our radicand becomes our base. That's our 10. Remember, there's a 1 there. This index number will be our denominator, and the 1 is our numerator. And for this one, it's going to be, our base is x. Our exponent is our numerator. And our denominator would be the index number, that's 2. So again, if you understand what's going on here, a very useful thing. All right, going on to number 15. And what we want to do is to convert them into fractional exponents. So again, our radicand is the base. That'll be a b to the 3rd. And we could put that in parentheses because our denominator will be 4 and our numerator will be 1. And then here we're going to use our base, which is 3m n to the 4th in parentheses. Our denominator will be 5, and our numerator will be 2. Now we're moving on to what we call negative fractional exponents. And they want to have the answer as a positive fractional exponent. And if you can simplify, they want you to do that as well. Now, just as we had before, when you have a negative exponent, to make a negative exponent positive, move it across the division bar, the fraction bar. So here, this is like in the numerator, up there. So remember, you're going to have a 1 to occupy the space of the numerator, and you just bring this down. And it has to be in parentheses. And then as your exponent crosses that division bar, it changes its sign. And why parentheses? Because if you took the parenthesis away, the only thing the exponent would refer to is the x, not the 3x. So by using the exponent, it maintains what your base is. Okay, up here, an interesting thing happens, by the way, and I'll show you that. I don't know if they're going to include it in your class, but whenever you have a fraction that is raised to a negative exponent, you can make this a positive exponent by taking the reciprocal of your fraction. So this is going to become then 27 to the 2/3 power. This doesn't change, only the sign of this changes as you take the reciprocal of that. So now you're going to take the 3rd root of 27 and raise it to the 2nd power. So the 3rd root of 27 is 3. 3 to the 2nd is 9. So this, in this form, eventually is going to equal 9. And the way we did it, since it was a negative exponent, we took the fraction and flipped it. That made it a positive exponent, and then we simplified. Now for number 19, this is already a positive exponent, so all we have to do is bring this up across the division bar, and it will become y to the 4/5. So all they're doing here is showing you that when a negative exponent crosses the division bar, the sign of that exponent changes. And for this one, there's our division bar. A to the 2/3 stays on top, because that's already positive. The 9 goes down to our denominator as 9 to the 1/2. And our b goes down as to b to the 3/5. But you recall that 9 to the 1/2 power is the square root of 9, which is 3. So we'll just put that there as a 3. Okay. Okay, as we go on, examples 21 and 22, they ask you to graph the function using a graphing calculator. And it looks like this for 21, and it looks like this for 22. Again, we're not sure you're going to be asked to do that, but if you are, I'm sure your teacher will give you some instruction on that. Now this next part is really crucial to our work, and what they're asking here is to multiply fractional exponents. And you might say, well, what rules do we use for this? Well, the same rules that we use when we are multiplying exponents, and that rule is to add them. And in order to add these fractions, we must have a common denominator. So here's the strategy I would suggest. You're going to put your 3 there, and what will your common denominator be between a 5 and a 10? And the answer is 10. So we know this one is already 1/10. And this one I have to multiply by 2. And then my denominator now is 10. That's what I'm looking for. But my numerator is 4. So this becomes 3 to the 5/10, which is equal to 3 to the 1/2. And remember, another way to write that was the square root of 3. That's what this is going to become. Now in this case, again, when we are dividing exponents, we're going to subtract as we move across the line, or its sign changes. So again, what will our denominator be here? Well, it's going to be a 12. So this is going to be times 3, but as we move it up to the top, this becomes a plus 9. This is a negative 9 twelfths in the denominator, but as we move it up to the numerator, it becomes a positive 9. And this we're going to multiply by 4, and that becomes a negative 4. So now we just add them, so we get 5 to the 5 twelfths. Okay? And let me check that, number 26. Yep. Okay, and again, we're just illustrating the kinds of things you're going to be doing, and you use, depending on what numbers you have and what they're asking you to do. Now here, you're raising a power to a power. Here we don't multiply. Here we're going to, here we don't add. We are going to multiply. Okay. So can you cross cancel anywhere? Because basically it's this. X 4/5 times 3/2. And the answer is yes. You can cross cancel a little bit. Here the 2 will go into there once. 2 will go into there twice. So you end up with x to the 6/5. And here again, you're raising powers to a power, so we're going to multiply. So again, whatever technique you use, this is going to be 2/5 times a negative 1/2. This 2/5 times this. Again, you can cancel out. So this is going to be a to the negative 1/5. Now here, the rules apply. Negative times negative make a positive. And this becomes b to the 1/10. Now to put this in its correct form, in the numerator we're going to have b to the 1/10. And in our denominator, we're going to have a to the 1/5. Because in the numerator here, this is a negative. We bring it across the division bar and the sign changes. And I see, since I didn't go my usual way, I skipped 23 and 24. Here they're asking you to use your calculator to evaluate this to 3 decimal places. So there are my 3 decimal places, and I would round off. The same here. And you might say, well, how could I put that into my calculator? Well, there is a special way that I wanted to show you. You're going to put 20, and you're going to use that caret sign on your calculator. And then what would that be in exponential form? Well, it would be 1/4. So you put that into your calculator as 20 caret, then a parenthesis, 1 divided by 4, parenthesis, hit enter, and that's what you get. Now you should try these ahead of time to be sure you're getting the right answer. And remember, when you put that in a calculator, you have to watch how to enter the negative sign. So this would be a negative 35 caret 1 divided by 5, and then enter. And you should get this. Okay. Okay, for these last 4, I really should let you have a go at it. And hopefully this is what you're doing. Instead of just watching it, pause the tape and then try these. And then if you need help, I'll explain them to you. But we had said that if you convert this to its fractional form, this is going to become x to the 15 over 3, where this is your index number and that's your exponent. And now that it's in fractional form, what will that become? Well, x to the 5th. And I kind of mentioned this in topic 7.1 and said we will be using that. So this is going to become CD to the 3/6, and the 3/6 reduces to 1/2, so then this just becomes the square root of CD. Or CD to the 1/2 power. This one, when I looked at it, I got a little, I said, oh, wait a minute, what's going on here? Well, just think what they've written here. This is the 5th root of m to the 1/2 power, isn't it? If I take away this radical sign, the radical sign is the 1/2 power of anything. So if I put this inside a parenthesis, this becomes m to the 1/5, converting this to its fractional exponent form, raised to the 1/2. So now this becomes m to the 1/10, or the 10th root of m. So I thought that was sort of interesting here, how they did that. And again, it's a challenge of what's going on and do you understand it. And by the way, I meant to say this throughout. You notice that throughout this, they're in the booklet, they're showing you the exponents as, and to me that's terrible to put that fraction like that. And then you don't know where, what's what. So 4 to the 1/2. When you're showing your work, always put your fractions over a horizontal fraction bar. That makes it so much clearer, especially when you're trying to convert and what goes where. Again, this is something you're going to have to memorize. So in this one, this is what's in parentheses now, x to the 3rd, y to the 2nd, and then it's to the 12 over 4. And what is 12 over 4? 3, yes. So you can just put a 3 there. And now you're going to do your multiplication. X to the 9th, y to the 6th. Ooh. Even though it looked rather complicated, by the skills you've worked on and practiced and hopefully mastered, you get the answers. And that will wind this up. Next section is 7.3 that we'll do.